All right, so the other type of problem here that I want to solve for you here is related to a question that students sent me through email. And I believe that lesson we started in class, so I'll go over some of those that didn't quite finish in class. Let's see, the performance task. There it is. Chapter 2, day 3 homework. So we did 2 and 4. Let's go over some of these at the bottom here. And if you need further resources, you could email me if needed. So what you're going to see here is that these series are going to be getting smaller and smaller. In other words, they're decaying, right? So no matter which one I look at, so I'm going to do 11 first and possibly, yeah, let's do one with the sigma. I want to try 14 as well. So let's see, we'll do 14. Decimal one kind of works the same thing with fractions. And we'll work out one of those. All right, so notice how for this one it stays negative here. So I got to figure out what number I'm multiplying by because it is, again, a geometric series. Instead then, for that. One more time. And then what you should notice is that I'm multiplying here by a fraction, causing this value to decrease. So I went from -2 and I'm dividing that by -3. So multiply by 2/3. So that's what this is saying. And I'm multiplying by 2/3. 2/3. 2/3. Now it's telling me it's going to go on like this forever, till infinity, till this number gets to as close to 0 as possible. And it's going to keep decreasing in this way. So what we can do here is, well, pretty much put a value here for n that's pretty huge or big, right? Enough for it to be, almost negligible when we get to, the 10th term, or in this case, the 10,000 term would be pretty negligible. Let me show you that. If I go with the calculator here, and then I write down -3, right? -3. And then I'm going to program this to be times 2/3 times 2/3. All right, now you're going to see, okay, those are the values that we have on our table, on our problem currently. And then when I press this more times, you're going to see this value that is pretty close to 0. So actually it's, just getting smaller and smaller here on this negative direction. Yeah, and it's scientific notation, meaning there's 4 zeros in front of this 1 when I move over -5 units to the left. So what that means for us is once we have this information down, I keep on using the same first formula here. So a sub 1 times 1 minus r. And in this case, n, let's make it some really big number here. Let's go with 10,000. I think that's what I was doing for the other rate problems. And then over 1 minus r. And we're doing 10,000 because this is going to get a sub 1 to be pretty close to 0, no matter which case we're talking about. So let's write that down. That's going to be -3 times 1 minus, in this case, 2/3 to the power of 10,000 all over 1 minus 2/3. Now, if it does say, you know, calculation can't handle that many digits, we probably need to just make it 1,000. But let's check if this works here. So -3 times, and then I'm going to put the fraction here. 1 minus 2/3 to the power of 10,000. All over 1 minus 2/3. All right, so syntax error, let's see. Probably didn't close off a parentheses here. Yep, didn't close off those first ones. I'm gonna go behind the power here to the right one more and then close them there. And that gives me -9. You know, and this is getting closer to -9. It's gonna give me that estimate that it's getting closer to that -9. If you notice, I could decrease this power by, actually, let's go back to this problem really quick. And let's make that power slightly different. You're going to notice that, you know, let's say I take off a 0 here. I think it'll make much of a difference. I'm still going to get close to -9. Let's see. Yeah, I think 10 will make it a slightly different. So I'm not going to make it less than this. But note that, you know, if you put a pretty big number here, I'll suggest always using 10,000 for any problem like numbers 1 through 20. Now, if we do one that looks more like the sigma notation, this already has all the info that I need. I don't need to come up with a list at all. What I need is that first term, which is -64, and then times 1 minus, in this case, r is -1/4 to the power of 10,000. So we could figure out the infinite sum here. -1 minus -1/4 here. So I bet I could do it that way too. So I'm going to do -64 times, and I'll do parentheses this, 1 minus, then I'll need the other parentheses, -1/4 to the power of 10,000. And then I'm going to close the parentheses at the very end this time. So this is going to be 1 minus -1/4 close there, and then close at the very end here. It should tell me the value it's approximating. So I could put -256/5, or I could also say that it's getting close to -51.2. -51.2. Now, if I put another 0 here for the power, it should more or less tell me the same answer. So let me change that. Let's do 1 less 0 here so you can kind of see it probably still works with 1,000 here. Oh, that was the previous one. Oh, that's the one. Let's go there. Let's go 1 less 0 here. Still going to give me same answer there. And if I go 1 less 0 than that, it might even still work too. Yeah, and it's still the same number. What this is saying is, you know, we got a number that series that starts with -64. It's multiplying by -1/4, making this number really, really small. eventually that number is going to become almost zero, but not necessarily zero. And when you use a value like 10,000, this is pretty big, meaning eventually it's going to become this value that's pretty close to zero. So this part is almost negligible there. All right, so that's my third video here. I'm going to go ahead and share that next. All right.